So one of the privileges of the Keck community is the ability to take advantage of time swaps with the Subaru telescope, which has many capabilities that Keck does not. So it's a real leveraging opportunity. And an important part of these meetings is hearing about the status of and the future plans for Subaru. So we'll hear now from Subaru Director Michitoshi Yoshida to talk about Subaru, and his interests are in galaxy superwinds, gravitational wave burst sources. So he's well versed in all the science we're interested in. We just need to persuade him to do some more on exoplanets. Professor Yoshida, please go ahead.
Okay, so hello everyone. I'm Michitoshi Yoshida, Director of Subaru Telescope, and I would like to thank Hilton and the organizers for inviting me to the Keck Science meeting. It's my pleasure to talk about the Subaru Telescope update at this time. Okay, why? Okay, so and last year was the 20th anniversary of Subaru Telescope. So and we had the Subaru 20th anniversary symposium at the Waikoloa Beach Hotel. Waikoloa Beach Marriott in Hawaii, and last November, and we had 244 participants in this symposium, and including and some of you and Hilton and others participated in this symposium, and thank you very much. Okay, so and first I'd like to introduce our instrument status. And currently, we had actually 6 facility instruments, and but one of which, the mid-infrared camera and the spectrograph comics, was decommissioned in this summer. So now we are operating 5 facility instruments, 3 optical, 2 near-infrared. And also, we are now operating 2 visiting instruments, one of which is IRD, and the other one is CARIS. And the comics are retired on July 30. So last open observation was performed on July 30 this year. And actually, the comics is one of the first generation instrument of the Subaru telescope, and it started its science observation in 2001. So nearly the 20 years operation of comics produced many science papers. And this is some examples of the recent science results of comics. The first one is the Jupiter mid-infrared observation, and the comics revealed that Jupiter's stratosphere is heated by the solar wind plasma. Actually, the heating is closely related to the aurora of Jupiter. And the second one is the comet observation with comics, and the comics identified many mid-infrared emission bands from the organic molecules. Okay, so and the next, I move on to the open status of Subaru telescope. This is the regular open night statistics. Actually, this is the oversubscription rate of proposals. So please see this green colored line. That means that shows the oversubscription rate of the proposals. The number is shown here. So you see that the oversubscription rate with Subaru telescope is currently the 4 to 5, and so it means that it's not easy to get Subaru time. And this is the number of publications. Currently, around 140 papers are published per year. And this year's production rate is very high. So as of September, we already have more than 120. So maybe, yeah, this year's production rate will be higher than the other years, I think. And this is observation time statistics, and the left-hand side is 19B, and the right-hand side is 20A. So unfortunately, so these issues, road blockage or COVID-19, due to these issues, we lost many observing time. I think that this situation is the same as that of Keck, and the observation success rate is slightly more than 50%. It is not good, but it is not inevitable. So that is time observation time statistics in this 1 year. And next I briefly talk about the Keck Subaru time exchange results. So the currently the oversubscription rate for Subaru to Keck time, it means the Subaru community proposed Keck time stays very high, the 4 to 10 in terms of number of nights. So, and Keck is very, very popular for the Subaru community. And the current most demanded Keck instruments for Subaru community are the Mossfire and the Dymus plus Elvis. And on the other hand, the Keck committee want to use HSC. So 70% of Keck users submitted HSC proposals. And now currently the HSCQ mode observation is available for Keck community. So this is how this pie chart is instrument statistics from Subaru to Keck, and that's for the last 4 years. You see that the Mossfire is the most popular instrument for the Subaru community. And this is the Keck to Subaru nights approved. So the 70% of Keck users want to use HSC. And the second one is comics, but comics was unfortunately decommissioned right now. And this is the oversubscription trend. Left-hand side is Subaru to Keck time exchange, and blue color bars the proposed nights of observation, and red color means the approved night. You see that the oversubscription rate is very, very high. In this year, nearly 10. For the Subaru community people to get the Keck time is very, very hard and difficult. But it's very happy for the two observatories, I think. And we are now conducting the long-term project. We call it the Subaru strategic programs. And now we are running 2 SSPs, one of which is the HSC SSP. 330 nights are allocated to this program that is ongoing. And we started a new SSP last year, that is IRD SSP, and 175 nights are allocated to this program. This program is dedicated to searching for planets like Earth around late M dwarfs with precise radial velocity measurement. And in a few years, PFS, prime focus spectrograph, will come. And after that, we will start PFS SSP. Currently, 360 nights will be allocated for this program. And the next topic is the future instrumentation of Subaru. Currently, these 2 instruments are the major instrument of Subaru telescope, HSC and IRD. And in a few years, PFS, prime focus spectrograph, will come. And then after that, we are now planning to develop the wide field infrared instrument. We call it Ultimate Subaru. And this instrument will be supported by the GLAO. And using GLAO, and this instrument will have the capability of wide field, high spatial resolution near infrared observation. That is a PFS. Maybe many people have already known this instrument. That is a fiber FET multi-object spectrograph, and 2,400 fibers will be installed across the field of view of 1.3 square degrees. Fiber module, a fiber positioner will be installed at the prime focus, and 4 spectrographs will be installed inside the dome. And the fiber, connect these two components. And this is the PFS status. And all of the Cobra fiber modules were successfully installed on the prime focus instrument of PFS. That is the picture. You can see the 2,400 fibers installed at the focal plane of PFS. Okay, and spectral module 1 is being tested in the Yama dome, and the spectral module 2 is being commissioning at the RAM in France. Maybe that will be shipped in this November. Third spectrograph is being assembled, and maybe in mid-2021, this module will be shipped. And fiber cables are one of fiber cables in near completion in Brazil, and that will be shipped to Subaru in October or November. That is the status. And this is the concept of ultimate Subaru. This is a wide field near field observation facility using GLAO. 4 main components of ultimate is the multiple laser guided system, deformable secondary mirror, wavefront sensors, and wide field near infrared instrument. And we hope to start the science operation with this instrument in 2026. Okay, so, and this is the Subaru wide field capabilities in 2020s, HSC optical wide field imager, and optical to J-band multi-object spectrograph, PFS, and near infrared instrument, ultimate. These 3 instruments will be the major instruments of Subaru telescope in mid-2020s. And this is the summary. Okay, I stop here. Thank you very much.
Okay, thank you all very much. Thank you very much for that talk about Subaru. It's really a remarkable complement to all the things the Keck community wants to do. We had one question about the Aurora on Jupiter, who had done it. I've answered that question live. It was a NASA JPL group who had done that using comics. And so that was the one question. I don't see any other ones, but I'll go ahead and ask one. With PFS coming online with so many fibers, 2,400,
yeah,
we could imagine that there will be unused fibers in any given field. I mean, how do you start thinking about the operation of PFS? Can you imagine users being able to request targets for unused fibers, and how would that possibly go ahead?
Okay, so that's a very good question. So we are discussing this issue very intensively inside the community. So, and also inside the observatory. So it is very difficult to use 2,400 fibers and effectively. So, and so at least the long-term programs, SSP programs are now considering the efficient fiber use for their programs, because they will conduct a very large survey, and the cosmology survey, galaxy evolution survey, and the galaxy archaeology survey. So that kind of well-designed survey program can use that kind of huge number of fibers very efficiently. But for the open use, general open use observers, sometimes it is very difficult to, sometimes it is impossible to use all the fibers for their observation. So, and we are now discussing the fiber sharing between different proposals like that. So, and one example is Quasar survey can be included in the galaxy survey because the number density of quasars is not high. So, and it's easily included inside the galaxy survey or something like that. But it is a very difficult problem, and we are now discussing.
Okay, thank you very much. We have another question here from Thane. Could you talk a bit about the high contrast imaging instrumentation and the future plans on Subaru to maintain that capability?
Okay, so, and I have not mentioned the high contrast instrumentation, and but we have now the high contrast instrument Caris, and empowered by the SKEX-AO. And we are thinking that SKEX-AO and maybe the advanced SKEX-AO will be the very good test bench, test cases for the TMT AO system and the high contrast instrumentation. So we will continue this activity, even if the wide field instrument will be the major instrument for Subaru telescope, but we will continue the high contrast and imaging or the spectroscopy capability activity in Subaru telescope.
Okay, thank you very much. I think we've run out of time. I'd like to thank both observatory directors and John O'Mara for very informative talks.